In this video, we're going to take a look at two transformations that we will apply to different shapes. And when we look at the word transformation, in there we see the word transform, which means to change or to make different. So we're going to be changing shapes by two different transformations. The first is translation, and that is often referred to as a slide, where we just take a shape and we pick it up and we move it somewhere else. And we can remember that by looking inside the word translation. We see SL, which reminds us that we're going to slide. The second transformation that we have is reflection or flip. When you take a look in the mirror and you have words on your shirt, or if you take a selfie with the camera on your phone, you'll see a lot of times things get flipped around backwards, and that's our reflection. And again, inside of the word reflection, we can see FL, and in flip, we can see FL as well. So that's a neat trick that you can use to remember. If we look at the translation, we see that the snowman ends up exactly the same as what we started with, just in a different place. Whereas in the reflection, his arm here is on the left, now it's on the right. The broom is on the right, then it moves to the left. Everything switches places. But the shapes themselves are still the same, just with some minor changes. Some important vocabulary that we want to know is right here. A pre-image is what we start with before we do a transformation. So pre there is our prefix for before we do the transformation. And then our image is what we end up with after the transformation. So it's an image of our original. It's important to remember that horizontal means you're going left and right along the x-axis, and vertical means you're going up and down along the y-axis, and that's going to be important as we do these different translations. Our first one that we have here is to translate the point N right 5 units and down 4 units. Since we're moving right, that's a horizontal translation, so we could write that as 5 units horizontally, and then down is vertical, so we could write that it should be down 4 units. We're going to make that negative 4 units vertical. You want to go ahead and make this change in your packet. The 4 tells us how many units we're going to move. Vertical tells us that we're going to move up or down, and this negative means that we're going to move down. So in my graph, I'm going to start by counting out right 5 units. So I'm going to count 1, 2, 3, 4, 5. Then I have to do the second part of my transformation, which is down 4 units. 1, 2, 3, 4. And I'm going to draw my new point. And then since this is a translation of N, we're going to name it N, but with a little tick mark after it that we call prime. So we're going to name this N prime. I'm going to write that out here. So this is what we say, N prime. The coordinates of our new point, again, we start from the origin. X is our side-to-side coordinate, so how far do we move here? We count 1, 2, 3 units to the right. And then our y coordinate, we come down 1 unit, so it would be 3, negative 1. All right, we can also do this with a whole shape, and we just repeat the process we did before, just moving each point at a time. So here we're going to move our triangle left 2 units, or horizontal negative 2. Negative 2 meaning that we're going left, and up 7, which is our vertical 7. So up goes with vertical, left goes with horizontal. So again, I'm going to do this each point at a time. So I'm going to start with W. I'm going to move left 1, 2, and then up 1, 2, 3, 4, 5, 6, 7. And I'm going to name that W prime. Then we're going to take V and we're going to move left 1, 2, and then up 7. 1, 2, 3, 4, 5, 6, 7. We're going to name this V prime. The last one is X. We move left 1, 2, and then up 1, 2, 3, 4, 5, 6, 7. And that's going to be X prime. And now if I connect the dots here, I can see that my triangle looks exactly the same as what we started with. Same size, same shape, facing the same way. It's just in a different location. There's another way that we can write our translation directions using coordinate notation. So remember that our normal coordinate pair is x, comma, y. I'm leaving some blank space in here because we're going to use that to write our directions. And the first direction was that we moved left 2 units. And that was our horizontal direction, which goes with x. And since we're moving to the left 2 units, that was our -2, I'm going to take my original x coordinate and I'm going to subtract 2. So if we look at w, w was originally at -3, 2, and w prime is now at -5, 5. This was -3, -2. If I do -3 minus 2, I'm getting 2 more into the negative, we get to -5. Then for y, our vertical translation was up 7 units, so vertical is y. We're going +7, so we're going to add that here. And my y coordinate for w was -2. We add 7, and we get +5. And we want to remember again that translating a figure does not change the shape or the size, just where it's located. Okay, go ahead and pause the video and try each of these questions in your packet. Alright, so we'll check this first one. Hopefully you're able to translate the shape. We had x plus 3, which means I'm moving every point 3 units to the right because it was positive. And then we had y minus 5. Y is our up and down, and since it's -5, we're going down 5 units. So for E, we'll just show an example. We went 3 units to the right, and then we went down 1, 2, 3, 4, 5. We label that E prime to show that it's the new point, and we repeat that process for all the other ones. And then when we're done, we connect the dots to show the new shape. We can see it's the same size, oriented the same way, just in a new location. Now for the next one, we're kind of working backwards. We want to write the rule. The first thing we need to look for are these primes, and that's going to tell us what's the image and what's the pre-image. So this is our image, and this is our pre-image. This means that the shape on the right is what we started with. So I'm going to pick one point to focus on, and I'm going to use point S. So now I'm basically just going to figure out how we moved from S to S prime. And we can look by going from blue to black, black to blue. I'm going to go the direction that we would normally go. So if we look, we can see that to get from S to S prime, first we moved up 1, 2 units. So that's a vertical translation of +2. And then we move left 1, 2, 3, 4, 5. So that's a horizontal translation of -5 because we went to the left. So if we wanted to write that in coordinate form, we would have x minus 5 and y plus 2. And we could check that by checking another point. So we could say, okay, 5 to the left, 1, 2, 3, 4, 5, and then y plus 2 would be up 2, 1, 2. We end up with u prime, so we know that that's correct. All right, the other transformation that we look at is called a reflection, and this is the one where, again, when you look in the mirror, things look pretty close to what they actually are in real life, but they're a little different because things are flipped over or flipped backwards. Our important words here are going to be line of symmetry, and this is going to be the line or the axis that acts as our mirror. This is going to be the line that we reflect over. So the very first thing that we're always going to do is figure out which axis we're reflecting over, and we're going to highlight it or circle it so we pay attention to what we're doing. So here this says to reflect point D over the x-axis. So I'm right away going to go and I'm going to either circle with my pencil or highlight with a highlighter. This got really big. The x-axis. And now that's going to act as my mirror. So for my reflection, I'm going to count how many spaces away my point is from that axis. So it's 1, 2, 3, 4 units away from my line of reflection. That means when I draw my image, it's going to be 4 units away, but on the other side. So I'm going to count 1, 2, 3, 4, and this is where I'm going to draw my image. And if we look, we see that they are both 4 units away because we reflected it. Now we're going to do a reflection again over the y-axis. So I'm going to circle my y-axis here. And we're going to do the same thing. We're going to count how many units it is from our point to the axis. So we count 1, 2, which means that we're then going to go 2 units past the y-axis, 1, 2, and draw our new point there. So the distances are always the same, just on opposite sides of the axes. We can do the same thing with a triangle. So here we're going to reflect over the x-axis. So again, I'm going to highlight that. I'm just going to draw that in there. Okay. And now we're going to do the same thing. This is all about counting. So if you can count, you can reflect shapes. So we're going to start with G. G is 1 unit to the axis. So I go 1 unit past and label it G prime. Next I go to F. This is 1, 2 units there. So we go 1, 2 units past and label it F prime. And then we do H. 1, 2, 3, 4, 5 units to the axis. So I count 1, 2, 3, 4, 5 units past the axis. Label it H prime. And then the last thing I have to do is connect the dots. And we've got our reflection. Reflection does not change the size or the shape, but notice now my triangle is flipped over, it's facing a different direction. Go ahead and pause the video and see if you can reflect this triangle over the y-axis now. Alright, now we want to highlight our y-axis so we know where we're reflecting, and then for each point we count how many spaces to the y-axis, and then the same number of spaces past. Spaces to the axis, spaces past. And now the last thing we want to be able to do is to identify the axis where we reflected. So pause the video, see if you can identify the axes of reflection for each graph. If I look at this one, I can see that the y-axis sits in between my image and my pre-image, so I know that's the axis we used for reflection. If it were the x-axis, I would be able to see parts of the graph on both sides of the x-axis, but there's nothing above it, so we can't have reflected over it. In the second one, I've got my pre-image above the x-axis and my image below it, so that means that we reflected over the x-axis. Even though we've got a graph on both sides of the y-axis, if you'll look, you'll see that we have our pre-image here and our pre-image, and they don't quite match up. Whereas if I look at the above and below the x-axis, we can see those matching parts.